All right, today we're working with inequalities, but we are working with inequalities that are nonlinear. So we've learned about quadratics, and we've learned about rational equations, right? The big fraction-looking things. And today we're learning about how to work some inequalities with those. And the general idea, our general set of steps, is going to be to factor, 2, set the factors equal to 0 and solve. Step 3, place the solutions on a number line. And then step 4, we have to test values in each section of our number line. Okay, those are kind of our steps to follow for today. So I'll walk through a couple of examples here and then set you guys loose on your homework. So the first example here, x plus 3 times x minus 3 is greater than 0. So first we're going to factor, and it's already factored for us, so we're done with that already. Next, we're going to set each factor equal to 0. Okay, so x plus 3 equals 0, x minus 3 equals 0, and we get x equals negative 3 and x equals 3. Next, we're going to place those on a number line. So our number line here, there's our number line, and we need to place in ascending order negative 3 and 3 on the number line. And then the last part is we're going to test values in each section. So we need a test value for this middle section, which the easiest thing to test is going to be 0. And actually I'm going to do this in red. So I'm going to test 0. The easiest thing to test on the far right is going to be 4. Try to keep it as small as possible. And the easiest thing to test on the far left will be negative 4. So I'm going to test all 3 of those values to see if they work. And when I say test, I mean I'm going to plug them in to my into my inequality and see if they work. Okay, so let's start with 0. 0 plus 3 times 0 minus 3 is supposed to be greater than 0. Okay, so that's 3 times negative 3, which is negative 9. And is that greater than 0? No, negative 9 is not greater than 0, so no, we'll say no, and we'll give this section an X. That means that all of this entire middle section is out, all right? And when I say out, I mean it's not part of our solution set. Remember, this is an inequality. So our answer is not going to be x equals. Our answer is a whole range of numbers, a whole set of numbers that you could plug in for x to make this side greater than 0. So whatever that range or set of numbers is, we just learned that this middle section is not part of it because we tested a value from the middle section and we saw that it did not work right there. Okay, so let's test something from the far right over here. So 4 plus 3 and times 4 minus 3 is greater than 0. So 4 plus 3 is 7. 4 minus 3 is 1. That is 7. That really is greater than 0, yes. And so this whole section over here works. And then if we test negative 4, so negative 4 plus 3, negative 4 minus 3 is supposed to be greater than 0. So negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. And negative times negative is positive. And so 7, positive 7 is our final answer there on the left, which is greater than 0, yes. Yes, that is greater than 0, so it does work. So what we just learned here is that all of this section over here works. All of this section on the right side works, but not the section in the middle. Not the section in the middle. Okay? So our answer is everything on the far left, negative infinity, 2, because if I had to call this far edge something, I could call it negative infinity on the far left. If I had to call the far right something, I'd call it infinity, right? So everything from negative infinity to negative 3 works, okay? And then everything from 3 to infinity. Now I held off on putting my parentheses on 3 because I need to double check. What is our inequality? There's no equal to part, so we use parentheses for those negative 3 and 3 values. Okay? So this is our final answer, those two ranges of numbers. And we got to them by working the number line. We put our solutions on the number line, and then we checked a value in each section to see if it worked or if it didn't. Okay, that's our procedure for these nonlinear one-variable inequalities. So let's try another one. So we've got this in factored form already. That's great. X minus 4 equals 0. So I'll set each factor equal to 0 and solve. So x equals 4 and negative 3. And then I put those on a number line. So there is my number line. Negative 3 and 4. And then I'm going to choose values to test on this number line. I'm going to try to test 0. I'm going to try to test negative 4 and 5. I'll just see if those values work. Okay, so x minus 4, x plus 3. So 0 minus 4, 0 plus 3 is supposed to be greater than 0 in this case. It's not always going to be like that, but it just happens to be in this case. It's supposed to be greater than 0. And let's see if it is. Negative 4 times 3 is negative 7. No, that is not greater than 0. So once again, this middle section is out. Okay, we'll check the left side here. Negative 4 minus 4. Negative 4 plus 3 is greater than 0, so that's negative 8. Times negative 4 plus 3 is negative 1. And negative 8 times negative 1 is positive 8, which is greater than 0. Yes, it is greater than 0. So this side gets a check mark because it works. And then when we move to the far right side, so 5 minus 4 times 5 plus 3 is supposed to be greater than 0. And then let's see. 5 minus 4 is 1. 5 plus 3 is 8. 1 times 8 is 8, which is greater than 0. So this side gets a check. So once again, everything on the far left worked because we tested a value in that section and it worked. Everything on the far right worked, but everything in the middle was out. It did not work. Okay, so if I call my far left edge negative infinity, I call my far right edge infinity. So my answer intervals are negative infinity to negative 3 and 4 to infinity. And because of the inequality, there's no equal to part, so I use parentheses on the negative 3 and the 4. Okay, so those are inequalities for when it's just quadratics, we'll say, quadratics. But when we get into things that are not set up in factored form, like quadratics that are in standard form, we're going to have to factor them. So like on this one, I'm going to have to start with the greatest common factor. If I factor this, this is x times x minus 4 is less than or equal to 0. So now I have it in factored form, and I can set each factor equal to 0. X equals 0, and x minus 4 equals 0. Right? Remember, the GCF is a factor. It does count. So I add 4 here, x equals 4. And so when I go to my number line, that does count as one of my solutions, and it does go on my number line. So we have 0 and 4 right there. And that does make a difference because now we can't check 0. We have to check values in between. So the easiest thing to check in this middle section is going to be 1. And over here it'll be -1 for that far left side. And then on the far right side, it'll be easiest to check 5. Okay, the smallest whole number is usually what I go for. So let's plug them in here. And you can plug them into the original, the x squared minus 4x, or this factored, x times x minus 4. It really doesn't matter. So I'll do the original. -1 squared minus 4x is supposed to be less than or equal to 0. So -1 squared is 1. Oh, I forgot to plug it in. So 4 times -1. -4 times -1 is +4, which gives you 5 is less than 0. Well, that is not true. No. So this far left section is out. Let's check the middle here. 1 squared minus 4 times 1 is less than or equal to 0. So 1 squared is 1. -4 times 1 is -4. 1 minus 4 is -3 is less than 0. That is true. That is true. So this middle section works this time. And then on the far right, 5 squared minus 4 times 5 is supposed to be less than or equal to 0. So 25 minus 20 is 5, but that is not less than or equal to 0. So this section is out. So as we look to the whole number line, we see that only this middle section ended up working. Only that middle section ended up working. The two outer sections were eliminated by the values that we tested. So our answer is everything in that middle section, everything from 0 to 4. And we use brackets because if you take a look at our inequality there, the equal to part means to use brackets. So 0 to 4 with brackets. Okay, and I guess on a number line I could be including closed dot, right? That would help me as well. So in the previous examples, those were greater than but not equal to. So they would be open circle, open circle, open circle, open circle, right? And I guess in Pearson, I think they use parentheses and brackets on the number line, so that's fine as well. A parentheses is an open circle, a bracket is a closed circle. Okay, so this works whether we have quadratics or not. Like this is larger than a quadratic. This is a polynomial to the 3rd degree, and it's got 3 factors, but it's still the same procedure. Set each of the factors equal to 0 and solve. X equals -3, x equals 2, x equals -1, and then put those on a number line. So there's our number line in ascending order. So -3, and then -1, and then 2. Okay? And then go choose values in between them to check. You have to check the outside sections as well. So I'm going to check -4, -2, 0, and 3. Those are the inside values that I'm going to check. So starting with -4. So -4 plus 3 times -4 minus 2 times -4 plus 1 is supposed to be less than or equal to 0. So -4 plus 3 is -1, -4 minus 2 is -6, -4 times, or plus 1 is -3. And so negative times negative times negative is negative, and then 1 times 6 times 3 is 18. Less than or equal to 0. Yes, that's true. It is less than or equal to 0. And then I'll check 2. All right, so checking negative 2 plus 3 times negative 2 minus 2 times negative 2 plus 1 is less than or equal to 0. Just a reminder there, we're plugging in these test numbers. We're plugging them into the original function, okay, for x to see if it actually does give us something that is greater or less than or equal to 0. Okay, so negative 2 plus 3 is 1. Negative 2 minus 2 is negative 4. Negative 2 plus 1 is negative 1. Okay. And 1 times negative 4 times negative 1 is 4, less than or equal to 0. That is not true. That's not true. So this section is out. Okay, and then we test 0. So 0 plus 3 times 0 minus 2 times 0 plus 1 is supposed to be less than or equal to 0. So that's 3 times negative 2 times 1 less than or equal to 0. That's negative 6 less than or equal to 0, which is true. So that section works. And then last, we're checking 3. 3 plus 3 times 3 minus 2 times 3 plus 1 less than or equal to 0. So 3 plus 3 is 6, 3 minus 2 is 1, 3 plus 1 is 4, less than or equal to 0. 24, 6 times 1 times 4 is 24, is less than or equal to 0. So that is out. All right, so let's look at the intervals that worked here. We've got everything on the far left from negative infinity to negative 3. That worked. That second section failed. The third section, everything from negative 1 to 2, that passed, and then the far right failed. So if I had to call the negative or the far left something, I would call it negative infinity. So everything from negative infinity to negative 3. Okay, I'm going to use brackets because of my inequality. There's the equal to part included in it. And then everything from negative 1 to 2. And that is my final answer, just those two intervals. Okay? All right, 2 more examples. We're changing gears here. I know this is a long video here, but when we have a rational equation like this, the procedure is really not any different. We're still going to factor it and set each of the factors equal to 0. So x plus 2 equals 0, x minus 3 equals 0. So x equals negative 2 and x equals 3. Okay? And we're still going to put those on a number line. We're still going to put those on a number line. So negative 2 and 3. Okay? And oh, I should have put closed circles here on this number line above. Closed circles. Okay. So on this one, I'm going to put a closed circle for the top, for the negative 2, because 2 came from the top. Closed circle. And I put a closed circle there because I'm referring to the inequality. If there's an equal to part in it, then that means I use closed circles and brackets. Okay? But the exception, any number that comes from the bottom, the denominator, is automatically excluded. Which means we use an open circle and we use parentheses for it. So the 3 came from the bottom. So it automatically gets an open circle. Okay? Automatically. It doesn't matter what the inequality says. If that number came from the bottom of this fraction, it automatically gets an open circle. It's automatically going to get parentheses when we write our answer. Okay? Other than that, our procedure is still the same. So we're still checking values that are in between these solutions here. We're checking those sections. So I'm going to check 0, 4, and negative 3. So negative 3 plus 2 over negative 3 minus 3. So that is negative 1 over negative 6. And that's supposed to be less than or equal to 0. So that's 1/6. Negative divided by negative is positive. That is really small, but it's not less than 0. So this far left section is out. And then we'll check the middle section here. 0 plus 2 over 0 minus 3 is supposed to be less than or equal to 0. So that's 2 over 3, 2 over negative 3, right, which is negative 2/3. And that is less than 0. So that works. And then we have 4 plus 2 over 4 minus 3 is less than or equal to 0. 4 plus 2 is 6. 4 minus 3 is 1. 6 is certainly not less than 0, so that far right section is out. And so our only section that works, our only interval that is a solution is that middle section, everything from negative 2 to 3, including negative 2, but not including 3. Okay, because 3 came from the bottom, and everything that comes from the bottom is automatically excluded. And that makes sense too, right? Because if I plugged in 3 to this equation for x, if I plugged in 3 right there, well, that would leave me with 0 on the bottom, which we've been over that. You can never have 0 on the bottom. It makes the problem impossible. So that's why anything that comes from the bottom is excluded, because if you plugged that number in for x, it would give you 0 on the bottom. Okay, so the bottom is always excluded. We can never have 0 on the bottom. All right, one more example here. So I have to empty out this side, get 0 on one side before I can start my number line procedures. Okay, so to get rid of that negative 2, I'm going to have to add 2, right? So add 2. So I end up with 5 over x plus 1 is plus 2 is greater than 0. Okay, and I need to get this into one fraction, right? So get into one fraction, one fraction, which means I've got to combine these two fractions as one. If I write 2 as a fraction, it's 2 over 1, and I'm going to have to get a common denominator. So this second fraction needs an x plus 1 in order to match the 5 over x plus 1. And so I have 5 over x plus 1 plus 2 times x plus 1 over x plus 1 is greater than 0. And then I can write them together. 5 plus, and I can distribute that 2x plus 1 over x plus 1. I'm sorry, 2x plus 2. 2x plus 2, distributing the 2, is less than 0. And then I just combine my like terms here. So 2x plus 7 over x plus 1 is less than 0. So now I can do my number line stuff. Now I can set each factor equal to 0. So 2x plus 7 equals 0. X plus 1 equals 0. Okay. Subtract 7. 2x equals negative 7. Divide by 2. X equals negative 7 halves. And then subtract 1. X equals negative 1. So when I go to my number line, I have negative 7 halves is about negative 3.5. So I have negative 7 halves and negative 1. And then I'm testing numbers in between. Oh, and which one came from the bottom? It was the x plus 1 that came from the bottom. So that one gets an open circle, or it gets parentheses. And then negative 7 halves, that came from the top. And anything that comes from the top, you have to refer to your inequality. So there's no equal to part, so it gets an open circle as well. Okay, so everything from the bottom automatically gets an open circle. Everything from the top refers to the inequality, defers to the inequality, I should say. All right, so let's check some numbers in here. I want to check 0 when I can because that's easy math. 0. I'll check -2 for the middle section, and I'll check -4 over here, right? -7.5 is like 3.5. And so -4 is going to check that far left section. Okay, so I had 2x plus 7 over x plus 1. So 2x plus 7 over x plus 1 is supposed to be less than 0. So -8 plus 7 over -3 is less than 0. -5 over -3 is less than 0. Negative divided by negative is positive. And positives are not less than 0. So that section is out. And I'll check the next one. So 2 times x plus 7 over x plus 1 is less than or equal to 0. So I have -4 plus 7 over -1 is less than 0. 3 over -1, which is -3, which is less than 0. So that middle section works. And then the far right, 2 times x plus 7 over x plus 1 is less than 0. So 0 times anything is 0. So I end up with 7 over 1, which is less than 0. 7 is not less than 0, so that interval is out. All right, so my final answer is everything in the middle interval, because that's the only section that passed. So -7 halves all the way to -1, parentheses for both since they have open circles. Okay. All right, that is it. Your homework should be posted already. Feel free to go work on it. It's 9 problems, so it's not that much, but as you can see, these can get kind of lengthy. So just be sure you're following all your steps. Don't skip steps. Don't try to do mental math. The most points that are ever lost on this section is people trying to do mental math in their head, doing these little checks in red, trying to do that in their head, and then they get lost, a sign error or something. So, all right. Don't forget you have a quiz on this material on Monday when I get back. We'll do a little bit of review, but you got a quiz then, so do not wait until Sunday night to do this. Get started on it right away and finish it this week.